We are going to work with exponents using the product and quotient rules. Product and quotient rules. So remember that a product is the answer to multiplication, and a quotient is the answer for division. So I'm just going to take this in its very most basic manner. So and we've gone over this, I think we've gone over this before. If we haven't, it's new. All right, so if I have something like x to the 7th, and I'm going to multiply that by x to the 3rd. So what is our basic rule? I'm multiplying x's together here. I'm multiplying x's together here. So the biggest thing is I see, that was my phone, and I'm going to silence it. The biggest thing that I see is that there is no addition or subtraction. Okay, so what does this mean? This means I've got 1, 2, 3, 4, 5, 6, 7 x's here. And here I've got 3 more x's. So the question is, how many x's am I multiplying together? So when I look and see how many x's I'm multiplying together, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my answer here is going to be x to the 10th. So exponents are a shortcut for repeated multiplication. So looking at this, all I had to do was add my exponents. And that seems kind of weird because it's a multiplication problem, but you add your exponents because you're counting how many you're multiplying together. So let's look at division. What happens if I've got y to the 5th over y squared? Okay, so come over here. That means I've got 1, 2, 3, 4, 5 over 1, 2. And we remember from previous videos that any number divided by itself is 1. And so this is 1 times y times y times y, which means that simplifies to y to the 3rd. So what could I have done? I could have subtracted my exponents. So take the top exponent minus the bottom exponent. So 5 minus 2 is y to the 3rd. And again, it seems a little bit weird because we are doing addition and subtraction when we're multiplying and dividing. But exponents are simply telling you how many times you're using that as a factor. Okay, so we are going to do a couple of examples. So for instance, if I have 6 squared, what is my rule? Do I leave that as 6 squared or do I find the answer? So that's kind of just a thing with practice. I know what 6 squared is because that is the same thing as 6 times 6. And I know that 6 times 6 is 36. 36 is a number that my brain is okay with. If I were to do 6 to the 12th, that would be a heifer number and my brain is not okay with that. Okay, so I would leave that as a 6 to the 12th. So 6 to the 12th is actually, let's look and see. 6 to the 12th power is probably going to fritz out. Oh my goodness, it is. There's hundreds, there's thousands, there's millions. So I've got 2.1 billion is what that is. Okay, so my brain is not okay with that. All right, let's try another one. We have a 2/3 to the 3rd power. So 2 over 3 to the 3rd power. So the question is, what have I raised to the 3rd power? I've raised everything in that set of parentheses to the 3rd power. So that changes into 2/3 times 2/3 times 2/3. Okay, 2/3 times itself 3 times. With multiplication, we go straight across the top and straight across the bottom. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So that is my answer there. Now another way that you could have seen this was that would have been 2 to the 3rd over 3 to the 3rd. That exponent belongs to everything on the inside. Okay, so, but I want you to see it both ways right now. And then I could have done, well, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So let's do a couple more. I've got 6/7, and I'm going to square it. So again, what does that exponent belong to? The exponent belongs to everything in the parentheses. So what that means is 6 times 6 over 7 times 7, which gives me 36 over 49. What I could have done was distributed that power and done 6 squared, which is 36, over 7 squared, which is 49. Either way, I get the same answer. Okay, but I'm going to keep showing you both ways just to give you an idea of what's happening. So let us flip the page. I now have y squared times y to the 6th times y. So remember, you've got to be careful. Math people are lazy, which means I don't write exponents unless I need to. So this is actually saying I've got a y to the 1st. So what does this mean? I've got a y times a y. I've got a 1, 2, 3, 4, 5, 6. And then I've got another y being multiplied. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives me a y to the 9th. What could I have done? I could have done 2 plus 6 is 8, plus 1, do not forget about the 1, plus 1 gives you 9. So I've got a y to the 9th. All right, a negative 6x squared times a 6x squared. So now my question is, I keep saying so now, my question is, what does this exponent belong to? He only belongs to the x. What does this exponent belong to? He only belongs to the x. So I'm just going to go ahead and write everything out. That gives me a negative 6 times x times x times 6 times x times x. And so the fun thing about multiplication and division is that they're a whole lot easier to work with. You just grab what looks the same and you multiply it together. So I've got a number times a number, or a constant times a constant. So watch your signs. I've got a negative 6 times a positive 6 gives me a negative 36. And then how many x's am I multiplying together? I've got 1, 2, 3, 4, so that gives me an x to the 4th. So what could we have done? I could have started up here and just said a negative 6 times 6 is negative 36. I'm multiplying 2 x's here and 2 x's here, which gives me a total of 4 x's being multiplied together. I have 6x to the 3rd times y, and I've got a negative 2 x to the 5th y squared. All right, so the bigger picture, I've got this chunk of parentheses times this chunk of parentheses. Do not fall into the pothole of thinking that this is a subtraction problem. Okay, so look between the parentheses. Between the parentheses is nothing. That indicates multiplication. So I've got this chunk times this chunk. So I'm going to go ahead and start shortening it up just a little bit. I'm going to multiply my numbers together. So 6 times negative 2 gives me negative 12. Now multiply your x's together. I've got 3 x's here. I've got 5 x's here. How many total x's am I multiplying together? I am multiplying 8 x's together, so I get an x to the 8th. How many y's am I multiplying together? Be very careful. There is a y to the 1st there. So there's 1 y here, and there's 2 y's here being multiplied. So that gives me a total of 3 y's being multiplied together. So that's a y to the 3rd. Okay? All right, I have negative 4m to the 3rd, 6m to the 6th, and negative 2m to the 6th. So let's look at the bigger picture. Do you see addition, subtraction, or do you see multiplication? So I've got this chunk of parentheses right smack next to that chunk, which is right smack next to that chunk. So this says I've got this chunk times this chunk times this chunk. So this is not a subtraction problem. That tells you negative 2 is being multiplied times everything else in this stuff. So I'm going to go ahead and take what is common. Since there's not addition, subtraction, I can just dive in and start multiplying. So I've got a negative 4 times a 6 is a negative 24. A negative 24 times negative 2 is a positive 48. So negative 4 times 6 is negative 24 times negative 2 is positive 48. Now how many m's are you multiplying together? I got 3 here. I got 6 here, which is 9. And I got 6 more here, which is 15. So I have a total of 15 m's being multiplied together. So simplified, that is a 48 m to the 15th. All right, negative 6y to the 7th, and I'm going to square that. So I have 2 ways of looking at this. What does this square belong to? So we're going to do order of operations. Look on the inside first. Is there anything for me to do? No, there's not. So move out. My next thing I need to do is exponents. So I see an exponent on the inside. I see an exponent on the outside. So this exponent belongs to everything on the inside. What that is a shortcut for is saying negative 6y to the 7th times negative 6y to the 7th. I've got this thing times itself twice. So let me tell you a pitfall that people accidentally fall into. So let's multiply. I've got a negative 6 times a negative 6 is 36. I've got 7y's here and 7y's here, which gives me a y to the 14th. Okay, now look up here. Remember, I can distribute this power to everything on the inside. So if I'm raising a power to a power, I multiply my exponents. And you just saw y, because I've got a y to the 7th squared, gives me y to the 14th. Now what people will forget is that this negative 6 is part of that. So I've got a negative 6, and I'm doing it twice. So I've got a negative 6 times a negative 6 gives me a positive 36. I've got a y to the 7th times a y to the 7th is a y to the 14th. Okay? All right, I have a new piece of paper. All right, f squared over g to the 7th. And then I'm going to raise that thing to the 7th power. So, is there anything to be done on the inside? No, there's not. So now I can distribute the 7 times everything on the inside. So I can distribute it to the f squared, and I can distribute it to the g to the 7th. Because this is where knowing the rules comes in handy. I don't want to rewrite this thing 7 times. So I can, but I don't want to. So I'm doing f squared times f squared times f squared times f squared, which means I can rewrite that as f squared to the 7th over g to the 7th to the 7th. This 7 belongs to both bases. And now if I've got a power to a power, I multiply. So that gives me f to the 14 over g to the 49th power. So those are exponents. Those aren't coefficients or anything like that. So f raised to the 14th power over g to the 49th power. So let's try another one. We have 3x to the 3rd over 4y to the 7th. And I'm going to raise that to the 3rd power. So I want you to see what we can do with this. This one is smaller. This one was 7 times. That's a lot of writing. This one is only 3 times. So again, there's nothing to be done on the inside. That fraction, the 3/4, is reduced as far as I can go. And I get 3x's multiplied on top and 7x's multiplied on the bottom. So an x to the 3rd over a y to the 7th. So I could rewrite this thing as 3x to the 3rd over 4y to the 7th, 3x to the 3rd over 4y to the 7th, 3x to the 3rd over 4y to the 7th. And now I can multiply straight across. So I've got a 3 times 3 times 3. Well, that's 27. So I have 27. I've got 3x's here, 3x's here, and 3x's here. So that gives me a total of 9x's being multiplied together over 4 times 4 times 4 is 64. And I got 7y's, 7y's, and 7y's, which gives me y to the 21st. So what I could have done was take this 3 times the 3, raised to the 3, times x to the 3rd to the 3rd, over 4 to the 3rd, and then y to the 7th to the 3rd. So that 3 distributes to every factor inside those parentheses. So I get 3 to the 3rd, x to the 3rd to the 3rd, 4 to the 3rd, y to the 7th to the 3rd. So that gives me my 27. This is a 3 raised to the 3rd, so I get a 9th. This is 64 because it's 4 times 4 times 4. And then I get a 7th to the 3rd, gives me a 21st. Okay, so either way I get the same answer. All right, I have a 2. Actually, let's stop this one and I'll come back for the last few.